Hello, this is John Graham. I'm going to show you how to import GKN files into the Gtilt inclinometer software. The GKN file format is used with GKN inclinometer equipment. If you load a GKN file into Notepad, it looks like this. It starts with 10 lines of header data, followed by the readings. Each line of readings starts with the depth and then the individual readings. The inclination readings are in digital units proportional to the sine of the angle of inclination from the vertical, where 10,000 units represents a 30-degree tilt, or arc sine 0.5. Or you can think of these values as representing 20,000 times the sine of the inclination angle. When you import this file into Gtilt, these exact same numbers will appear in the Gtilt readings editor. Let's start from scratch and import a GKN file. So we'll go File, New, File, Import, GKN file. We pick the first one, open. It shows us the header data. It mentions that it's going to set the probe sensitivity to 10,000. This is 10,000 units for a 30-degree tilt. That is appropriate for a GKN file. And we don't get a graph of cumulative displacement because we only have one data set. And to have a graph of cumulative displacement, you need a reference data set plus a current data set. If we can have a look at the graph of absolute position. Here's the graph of absolute position. I'll just set it up with symbols so that it's a little easier to see. And let's change the scale here. I'll enter 2000 and press Tab. And I'll put 2000 over here as well and press Tab. And so this represents the shape of the casing in the hole. It doesn't represent any displacement. It simply reflects conditions at the time of installation. Let's add the second GKN file. So import GKN, pick the second one, shows the header, and it pretty much falls on top of the original. Let's choose a plot that highlights the differences between the two surveys. We'll choose cumulative displacement A and B. There's not a lot going on here. We do see that there's a bit of movement here at about the 22-meter depth. That could be due to a little bit of instability of the casing within the borehole. Let's see what happens when we add the next GKN file. We'll pull in the third one. There we go, and let's pull in the fourth and fifth. So we can see that, yes, there's a bit of movement going on up here. It does seem to just represent movement of the casing within the borehole, though, because there's no real shear movement at that elevation. The depths on these plots are normally relative to ground surface elevation. So let's have a look at the main header. Casing stick up here. If we had a casing stick up of 0.5, that does make a little bit of difference to how it plots. Let's just hit close. It just corrects the position of these traces relative to the ground surface. Just to show the flexibility here, let's go to the main header and change this from metric units to English units. And we'll see that the depth is now called 400 feet instead of 124 meters or whatever. Let's save these 5 data sets as a GTL file so we don't have to import them again later. I've already named this file. I'm just going to use it again. So to sum up, we've saved all the data for this inclinometer up to the 5th of June in a single GTL file. Let's assume now that it's around mid-June, and we've come back to the project after being away for a bit, and we've got this new data, this new GKN file, and we want to look at the results. We go File, pull in the GTL file that we'd previously saved. That brings us up to the 5th of June. Then we want to add the GKN file to that, so we go File, Import, GKN file, and it'll be this one. We bring it in, and if we only had the one GKN file, then we could just go File, Save, and now it has 6 GKN files effectively, and there are 6 surveys. Let's just add the rest of the GKN files so we don't have to do it again. This one. So now we can see pretty clearly that there's about an inch of movement at this elevation, but as mentioned before, it doesn't actually represent shear movement because there's no displacement at that location. It goes out and back, and so it just means that the casing has sort of flopped over against the side of the borehole. Let's set preferences so that we can leave out the symbols for a bit and better see what's going on. Sorry, I didn't mean to do that. Anyway, here are the readings of the latest data set. I'll just go back to the very first data set and just show you that these readings are the same as the ones in the file. You might notice, though, that they're upside down in the sense that the GKN file lists them from the bottom up, whereas Gtilt lists them in the readings editor from the top down. So if you can see this 337, 243, that's on the top line rather than the bottom line, but it's at this depth of 1, so that's okay. Let's just take a closer look at what the readings are in the area where we seem to have all the movement. We need to move to the most recent data set. Instead of showing the readings here, I'm going to show change from initial. So this is a change from the initial data set. That's when the yellow background comes in. And you notice here that where the position of this cursor is in the editing table is shown by this dumbbell on the displacement plot. So that's a way of showing you which reading is related to which part of the graph. Anyway, you can see that the changes from the initial reading are clustered in this area. The ones in the 80 plus or A0 direction are pretty well of the same magnitude as the ones in the A180 or A negative direction. Similarly for the B directions. So there's nothing sinister going on here. It's all quite consistent with the casing having moved over to the side of the hole. So I'll just close that. Now that we've imported all the GKN files that we have for this inclinometer, it's appropriate to go File, Save, so that when we get the next set of GKN files, we don't have to go back and import them all over again. That's all I've got to say about GKN files. Now, just for interest, let's have a look at what's going on here at the 70-foot depth. Let's look at the absolute position plot. Now, there might be something happening around here, but we can't see it very well. So let's abandon the bottom 3/4 of the inclinometer just temporarily. So we go Edit Main Header, and it's a very deep inclinometer, so Let's change this to 60 readings instead of 248. We hit close. So now we just see the top 100 feet of the inclinometer, and we'll be able to see the displacements a lot easier if we change the scale here to something. Yeah, let's change it to 2 inches. I'll make it 2 inches for the B direction as well. Perhaps 2 inches is a bit much. Let's make it 6 inches. 6, tab, and then 6 and tab. Okay. Now if I press F5, we get to see each of these absolute position traces in turn. There's the first one, the initial, and then each additional one. And each of these stands alone. But you can see that they're gradually moving out here. And this affects both the A and the B directions. And it's at, 75 feet down to 85. So 70 feet to 85 feet is the part that's affected. Here, I'll just press it several times again so you can see how it's developing. You can even hold down the F5 key. That's a bit too fast, though. It's important to remember that when you experiment with data like this, changing the number of readings in the main header, you have to make sure that you exit without saving. So you go File, New, and you don't save the data. So that if we pull that file back in again, we get all our data. We don't lose the bottom 3/4. So to sum up, each time you get a new survey, you first load the Gtilt file for that inclinometer. Then you import the latest GKN file. Then you select File Save so that the data from the latest survey gets incorporated into the Gtilt file. Thank you for watching.